My presentation is focused on the gallium nitride semiconductors, which is thought to be post-silicon semiconductors. And I presented the blue LEDs, which is well known as the 2014 Nobel Award. And this material application is not limited to blue LEDs. We can use it as the ultraviolet light source for water or air purifications. And also, it can be used as the next generation power controlling units. So by which we can expect to reduce the electricity consumption. In case of LEDs, we can expect 7% reduction of electricity consumption, and by the power device, we can expect 10% reduction of electricity consumption. Duty is to commercialize the next generation power device as soon as possible. So by maybe 2, 3, or 5 years, we can expect the next generation power device by which we can save energy.
From my perspective, material science and engineering is foundational to all other engineering disciplines. If you're looking to build a better integrated circuit, you need improved electronic materials. If you want to build a better bridge, you need better structural materials. If you want to build better biomedical devices, you need better biomaterials. So I think this is true throughout the world, that material science and engineering is foundational to all other engineering disciplines.
You know, from my perspective, material science and engineering has evolved over the last few decades into possibly one of the most important fields because essentially it determines progress in a number of critical technological fields like transportation, medicine, energy, the environment. And its importance has continued to grow even more so over the last decade.
Well, material science is of course very important because it ignited more or less a lot of new technologies. If you look to your cameras, if you look to your computers, look to the cars, this all started with material science. So I think material science is very important and will still be very important in the future.
My presentation at the Imrc is entitled Mixed Dimensional Nanoelectronic Heterostructures, and it's looking at a combination of low-dimensional nanoelectronic materials. These include materials like carbon nanotubes, graphene, and so-called post-graphene two-dimensional materials such as boron nitride, molybdenum disulfide, and phosphorine. Each of these materials in their own right is of high interest for a variety of applications, including electronics, energy technologies such as photovoltaics and batteries, and biomedical technologies such as diagnostics, drug delivery, and tissue regeneration. And what the presentation is looking at is not these materials in isolation, but rather integrating them together into heterostructures, hetero meaning combinations of different materials. The other key word is mixed dimensional because we're combining different dimensionality materials such as one-dimensional carbon nanotubes with two-dimensional graphene.
My field of research is related to nanostructured materials, specifically nanostructured metals and composites. And so My research group studies ways to manufacture these materials in ways that are stable and that have properties that make them attractive for structural applications, that is transportation, energy, for example. So this afternoon I'll be speaking about the role of grain growth, which is a very important phenomena because grains in their characteristics determine mechanical behavior. So I'll be describing fundamental processes that govern grain growth, as well as some results from our research group.
Well, today at the Imrc I talked about my recent work in the last 10 years about complex oxide heterostructures, in which I showed that if you control the properties at the atomic scale, you can make them as a functional oxide in devices.
The idea of the presentation was to explain why material science, material engineering is so important for the competitiveness of any country, particularly the case of Mexico. Engineering is the field of science, is the field of knowledge, in which all problems of society are solved. In order for engineering to be more competitive and more innovative, we need to have material science and material engineering working together with engineers. That's why material science and material engineering is so important to engineering, and then why it's so important to the competitiveness of the country. So my presentation dealt on the importance of the academies of engineering working together with the communities of material science and material engineering, giving some examples on the applications of material science and material engineering to engineering solutions to societal problems, and then making a call to scientists and engineers on materials to be much closer to all fields of engineering in order to improve the competitiveness of the world, and particularly the competitiveness of Mexico.
Yeah, the evolution of this field appears to be in the direction of increasing complexity. My talk is a step in that direction, in that we're now not looking at each of the nanoelectronic materials in isolation, but rather integrating them together into heterostructures. And it is that pathway towards integration that leads to significant improvements in functionality and performance. For example, if you look at the modern day integrated circuit, if we looked at it 2 decades ago, it would have consisted of a very small number of materials. Whereas today in 2016, we see that almost all the elements in the periodic table are present in the integrated circuit. It is the pathway towards combining different classes of materials that the future is going to attempt to exploit.
Material science and engineering is hugely important in the development of new technologies because all technologies require materials, from some very fundamental work in electronic materials to technologies for medicine to technologies for environmental remediation. Really, materials are the foundation of every new discovery that has been done by humanity. And the idea here with material science and engineering is not only to promote the development of new discoveries, but also the development of new technologies that can benefit humankind.
Well, I think material science and engineering plays a key role in many of the important issues of the world that the world faces today. For example, many of the biggest challenges involve things like energy and clean water supply and all the advances that are needed in technology, and material science is a very broad field and allows, leads to major impact when breakthroughs are made, affecting all of these kinds of applications.
Also, I've been coming to this conference, the Imrc, for close to 16 years. I came for the first time in 2003, so it's been quite an adventure. I've enjoyed meeting new people here. I've enjoyed making wonderful lifelong friendships with even some of the people that I met originally in 2003, and so that continues. And when I started coming to this conference, it was somewhere in the vicinity of about 300 people, 400 people or so. We are now, greater than 1,500, and I think that is tremendous growth. And it's not just about the numbers, it's also about the quality of the presentations, the quality of the speakers. The globalization of this conference has been amazing. It used to start with, and it used to be that it was just a national kind of conference, people from Mexico. But now it's a global conference with people from all over the world. And I think that brings a very interesting global perspective to this conference that is shared, that allows this amazing sharing among everyone that is here. The other aspect of the conference that has grown tremendously is also the exhibits. It used to be just a few companies that were interested in coming to this, and now I think everyone recognizes the value of this conference for the material science community, the global material science community, and then there's a response with respect to that from the companies that are interested in interacting with people that are in the material science field that come to this conference.
I've been coming, this is actually the fourth time that I've come to the IMRC meeting. The first time I came, it was probably almost 20 years ago. So I've seen a lot of change over the years. The meeting was good the first time that I came, but it's even better now. It's gotten larger, but it still maintains this nice feeling of friendship, and it sort of feels even like a small meeting, even though it's not such a small meeting anymore.
The IMRC meeting, as I've said earlier, is now in its 25th year. My own experience with IMRC doesn't date back so long, of course. I have been to the previous one in 2015, and I can see a forecast, or if you wish, a prediction to the 2017. And my feeling is that this conference has really now become internationally as well as nationally very well established. You can view this from, for example, the projected forecast of symposia for next year, which seems to really nearly reach about 50 symposia in total, which would be a great success in my view. This year we already had a new record of attendees, becoming close to, I think, 1,800 who finally registered. So I hope and I expect that next year we break the 2,000 number.
Well, the International Materials Research Conference started around 25 years ago. It was an initiative created by a certain group of professors in Mexico City. And the idea was to create this environment for young researchers to promote their science and to disseminate the results and findings. So right now we're celebrating the 25th anniversary, and I think personally, I came here as one of the attendees, and then now I'm part of the organization partially. And I think it's a very unique opportunity for participants to disseminate their results, to create great network, and to promote collaborations as well. We have received Nobel laureates to speak to the attendees, as well federal agencies for the United States. It's a joint conference with the Materials Research Society in the United States, and as well from Mexico, which is the CONACYT, the Consejo Nacional de Ciencia y Tecnología, which they come and provide workshops so people can write proposals, get funded for their research, and so forth. So it has a tremendous impact on researchers, students, full-time professors, and to create this huge network nationally and internationally.
I have the pleasure to organize the Symposium Materials and Environment. This is the second time we organize this symposium at this great conference. We mainly discuss topics related to how the materials that we produce and we try to produce can affect the environment in favor of against. For example, at the moment we are developing nanomaterials. Nanomaterials is a very broad research area. However, there's very little research trying to understand what happens when these nanomaterials enter the environment. There are clear information that these nanomaterials can affect the environment, not in a very good way. So we need to be very careful when we try to develop new materials and just try to use them without actually looking at the effect that we can have on the environment. So that's what we're trying to discuss in this symposium.
I am coordinating Symposium C3, interfacing nano and micrometer structures to the bioworld. And it's really about bringing nanoparticles and microparticles in contact with biological systems like single cells, but also really with animals, and checking what the response of the biological systems is on these particles.
I had two presentations during this nice Imrc Congress, which had place in Cancun. I present one area of my job connected with carbon nanotubes decorated with noble particles. We try to do new nanocomposites. And I think that it can be used in the area of sensors, so that it can be used like sensors of harmful gases, and also like sensor in liquid atmosphere in human body. The second object of my research is connected with scaffolds. These scaffolds are made from titanium and from titanium alloys, and we try put some layers of biocompatible substances like hydroxyapatite and also titanium dioxide and alumina. It is because we would like to use it in human body, like implants of some parts in the head area and also in different parts of our body.
Okay, I'm an expert of a transmission electron microscope, and we are now developing some techniques to see or identify atom by atom in nanomaterials. So we are now showing many examples of the nanomaterials or low-dimensional materials characterized in atomic scale. So I'm going to present our most recent results of graphene or dichalcogenides. It's very single layer materials. And we can see single dopant atoms or single impurity atoms or even single atomic defects. They are quite important to predict some properties of the nanomaterials.